Elan is a microprocessor-controlled ankle-foot system that can detect different surfaces and different walking speeds and styles and actively adapt to them.
It is life-changing because once you are used to it and you know how it reacts, how it adapts, you can do simple things on your prosthetic side that you couldn't do with a fixed ankle.
Elan is able to detect different surfaces and different gait characteristics. It's very important that the ankle and the prosthesis can adapt to these different requirements. When an amputee will encounter an incline, it's very important that we do everything we can to effectively assist that action going up the hill, to preserve that momentum.
Elan can assist the gait by controlling the amount of energy going in and out of the springs. When the heel strikes an incline, the plantar flexion resistance increases, encouraging increased energy uptake in the heel spring. This energy is released at the moment propulsion is needed to assist the forward movement. As the body's center of mass moves forward, the dorsiflexion resistance is reduced, assisting forward momentum and propulsion.
The Elan gives you extra assistance up the hill, up the slope. You don't have to climb over the toes. You progress through the foot, through mid-stance, and you roll onto the toes rather than having to climb up over.
I was like if somebody was just coming behind me and pushing me just to help to, you say assist. Yes, assist. Just pushing in the back to make the ramp perhaps less difficult.
The human body has a natural speed of walking which is determined by how efficient the muscles can convert calories and energy into actual movements. And the body wants to move at a specific speed to ensure that this optimum speed and control is preserved.
The resistances at heel, toe, and ankle are controlled independently to ensure that the body moves across terrain most effectively. On level terrain, sensor settings affect heel spring stiffness and variable resistance in the ankle, and also affects the timing of resistance and energy release in the toe spring. Should stairs or other terrain be encountered, then the Elan will change to a suitable program mode for smooth transition, and adapt again on regaining level ground. The Elan has a speed boost for transtibial users, which enhances the dorsiflexion characteristics for faster rollover as the walking speed increases.
When a downslope is encountered, the propulsion of momentum isn't what's required. What's required is a safe, stable transition of body weight across the ankle. And there'll be a natural tendency to walk down the ramp at the speed where the gait would try and run away with that person.
When the foot encounters a downward slope, the plantar flexion resistance decreases so that the foot moves quickly and safely to foot flat. Dorsiflexion resistance increases to support the center of mass and add a braking effect. This also assists knee extension for safe and controlled descent.
Even if you are climbing and just after going down, it reacts immediately. Like if he was knowing that what is going to happen just after.
You tend to get less socket pressures travel up because it smooths out the lower end of the prosthesis. When those forces travel up the limb, it's a lot more smooth.
It is funny how such movement at the end make a so big difference even in the socket.
Yes.
Sensor feedback means that adjustment of the Elan can easily be optimized. The clinician has full control of the setup parameters at initial fitting via a wireless connection that allows minute programming adjustments to be made on screen as the user walks around in his or her preferred gait style.
After a few steps, you feel more stable just because the foot is totally flat on the floor in every situation. With a fixed ankle, the foot is winning, is a directive foot. With this one, I'm doing like I want.
If you're used to having a fixed ankle and you have an adaptive ankle, it opens up a whole new world because you feel so much more stable and you can do more.